Hey guys, it's Mike from Shamino's workshop. I have a second video on the Korbanth Bastila. I did one video which showed these particular chassis, which can be used in a single hilt configuration or in staff mode. But they are two complete chassis setups. They both have Proffieboards, recharge ports, they have batteries, 22mm bass speakers. So while they work in staff mode, each hilt, right, operates independent. And as I showed in my last video, I made use of these new Switch NeoPixel combination PCBs, which, really for this design, it just removed the wire, right? It removed the need to have a wire, the need to have wire slack, right? When you have to take the hilt down to access the Proffieboard, you'd have all that wire slack from the pixels and the switches, and trying to then get this back in could present a problem, because where is that wire slack going to go? Especially in this hilt, as you can see, there's not a whole lot of room between the top of the chassis and the switch holder. So that was the problem with the initial design of these chassis, which I corrected by using these. But I took it a step further and then created another staff mode chassis, which comes in two pieces. And so this video is going to demonstrate just how powerful these new PCBs are and what they'll allow you to do. And one other thing, I think I finally figured out what's wrong with my camera. It's a Sony a6000 camera, and apparently it has a 30-minute limit on video length, which I don't know if that was from a firmware update, or maybe that has always been the case and I just never had created a 30-minute video. The other thing people are saying is that the camera tends to overheat if played for that long. So I'm going to keep an eye on it, but what I'm going to try to do is break this down into shorter segments and then just edit and combine the video later. So if I get it wrong, forgive me. So I'm just going to try to keep a check on time. We're about 3 minutes in. So the first part is just going to be an overview. I'm going to show you all the pieces and parts that come with the kit that make up the chassis, and then we'll go and put the hilt together in single hilt mode. And then the third part will be the staff mode. So bear with me. So as we can see, the kit comes with two hilts, comes with a coupler to join those two together to make the staff, but it also comes with vented pommel caps in the event you're going to just use them in single hilt mode. So let's go over that. Let's go over the rest of the pieces then, right? So we went over what the kit includes. The kit also includes these little screw pieces, these little gribbly pieces, which cover the porthole. And we use the porthole to access a recharge, a 1.3 recharge port. And that's true for both the single hilt chassis as well as the new chassis. So what else? So we have those. Okay, so that's what the kit includes. So we've already gone over this hilt. This was made by Jed King, Mastercraft. Terrible. It'll be in the description. But Jed makes chassis. He does his own thing. He's got his own page, his own business. He does chassis designs, and I'm sure he does many other things. But chassis, Jed was the one that designed this chassis specifically for Korbanth. And then, as I showed in my last video, I modified it so it would support the Switch NeoPixel combination. I've reached out to Jed because I would like my own version of this chassis, one that will support a 28mm bass speaker, remove the Korbanth branding, and one other change, which I'll show. These were designed for staff mode, and it assumed the use of the coupler. As you can see, the threads on the coupler are quite long. And when you compare them to the pommel cap threads, there's a big difference there. So when you try to use this in hilt with this, there's a 16mm gap, which allows for the chassis to move. So what I've done in the meantime is just created a speaker spacer to fill the gap. So just a quick and easy solution to a silly problem. So that's the single hilt staff, and obviously there's no switches on here, right? It's fully removable. It would work if I grounded the switch pads, but the other idea is maybe add switches onto the chassis, recessed, so that when it's out, you could at least turn it on and off and test. But maybe we'll do that, because right, like I said or showed in the previous video, the switches are in here with a PCB, and also the other thing I modified, so the switch holder, besides holding the switches, holds a custom Saber Shop PCB on the top, and then it holds one of the new PCBs on the bottom. And the custom Saber Shop PCB on the top is allowing for the neck to get removed. There we go. So I just let that float. But that just allows for this to get removed, and it also makes installation a little bit easier. While it's another set of PCBs that you have to use, if you were to hardwire this to the switch holder, it would probably be more challenging than just doing what I did and using some more PCBs. So So that blade side holder is just getting tangled up onto the on the threads. I don't know why it has to decide to give me this problem right now. Come on. There we go. No, doesn't want to. Might need to make that blade side holder just a tad thinner so that it bypasses. But that was the idea, right? The concept was, if you wanted to, it'll make the installation easier, but it also allows for quick disconnect of the emitter. Okay, so with that said, we'll orient the recharge port to the port hole. And we can see the recharge port access right there. I happen to use one of these little adapters for charging that with a standard charger, but I also use it to keep that from rotating. So now all we have to do is add our spacer. Add our pommel cap.
And may the force be with you.
And she boots up.
Nothing. I am Bastila.
And I went over the fonts in the previous video. There's 3 fonts on here. One's Bastila, because it's the only one I could find, and the other actually Satal.
I see. Nothing prepared me. I am Bastila.
These 22 are just not the greatest speakers, which is why I want to get them upgraded to 28. It's not even touching anything, but you can hear the crackling, so I might need to replace those speakers. But I don't plan on using the single mode. I'm going to keep mine in staff mode. Right, and then we do the same thing on the other side, on the other hilt.
Maybe you've heard of a little thing called the Force?
Let me see if I can try reducing the volume. No, still got some static. So I don't think it's the volume. I think it's just these crappy speakers. I'll go real low. But that's kind of pointless, right? So okay. And it's definitely not hitting the spacer. I made that spacer way wide. The internal is 28 where the speaker's 22, so it's definitely not hitting anything. Or is it? No, it can't possibly be. Because that doesn't go in. It's cracking even without the spacer, so it's just the speakers. I don't know, maybe I damaged them. Not the point of the video though. Okay, and then obviously you can close up the portholes. Right, and you got your 2 hilts. Very cool. Okay. I'm gonna stop the video and then restart the video just so I don't run out of time. But in the next part of the video, I'm gonna demonstrate the staff mode and sort of the quote-unquote plug-and-play feature, which is really what I'm trying to showcase here. Is, you know, with what these new PCBs can do for us. All right, so I'm going to stop and pick it back up. Okay, so let's break it down. Okay. Maybe that's why. I didn't glue these speakers in. I don't know why that would matter. These also help to retain the chassis. I'll show you what I mean. Should be able to pick it up on the video, but you can see there's a recessed hole. So when the chassis is in and then you add this and screw it in all the way, there's still a little bit of wobble, but it keeps the chassis at least from rotating. You'll get a little up and down movement, which does cause a problem with the pogo pins, right? If it's allowed to go down, you might lose connection, which is why I did the speaker spacer. As you tighten the pommel cap on, the spacer will add the tension from the bottom and keep those pogos in place. Okay. So let's go over the staff mode chassis. It's a two-piece chassis. One piece goes in one part of the staff, and the other piece goes in the other part, or the other hilt. As you noticed, these hilts have a 31 millimeter inner diameter. So lots of room for a bigger battery. This is a 21700, which means it's 21 millimeter in outer diameter, 70 millimeters long, 21700. Gives us 20 amp max discharge and 5100 milliamp hours. So more fuel, much larger discharge, max discharge rate. So this battery can support two full-length blades. I don't have two full-length blades to test out full runtime, but you know, my guess it's going to be in the 30-minute range, maybe a little less, maybe a little more. Will also depend on your blade style effects and colors, right? If you're running a white blade, that's using full RGB, so that'll use more power than if you're just running a single color. So the first part is literally just a battery holder. It does not have a recharge port. I was going to put the recharge port here, but it would have, I think, thinking through it, it may have added more wires running up to the other chassis. So I kept it simple. The recharge port is actually here in this because there was more room, and it would, you know, it might also give me the ability to add a kill switch. I've even been toying with the idea of using a 2.1 recharge port. I'm not considering this the final. I would consider this like the first draft. It's fully installed, it's fully working, but you know, I might want to make this look pretty. I might want to add switches. So I have other ideas for this, but this is my first iteration and it's completely working. So this first piece, as you can see, it has one of my new PCBs, but you'll see it's missing 4 pogo pins, and that's the switches. I only want one set of switches in staff mode to operate both blades. So I intentionally did not wire the switches. So that, and you could, right? You totally could. You could, which way is it? This way. So for me, there was no need to wire the switches. And trying to pass the switch wires through, I ran out of pogo pins, and I'll explain why. So here, right, simple battery holder. This was my first attempt at a removable battery chassis, and I think I did a pretty good job. So negative with the spring, positive up here, right, obviously. So this goes in this way. And we have 2 sets of the new PCB. We have the top set, and then we also have the bottom set. which is going to allow these two to join. If I were to touch these two together, it would power it up. That's why I'm not doing that. And I don't want to short out any by holding it. So keep that in mind. Now, there are 6 rings to this PCB, right, which you can see here. There's 6 rings. I had to use 4 of those rings in order to allow battery, positive and negative, to pass through. So positive is the outer ring, battery negative is the next ring. And then, yep, this way. This middle pogo pin is meant to be common switch ground, but I used it for data. The third ring, normally used for data, it has 4 pogo pins. Doesn't make sense to me. Data doesn't need 4 pogo pins. So I repurposed that for NeoPixel ground. Because we're going to be supporting a full-length blade, it made sense to use the third ring from the outside. Third ring from the outside has 4 pogo pins. Makes a lot of sense to put a high-powered application through that, right? So that's what I did. I repurposed it. That only leaves me with 2 rings. 4 pogo pins, but 2 rings. That's not enough to implement the buttons. So I simply ran out of rings. But with that said, this is going to go, so it's oriented where the recessed part goes pommel side. And the reason for that is because when you use the coupler, the inner diameter of the coupler reduces from 31 to 28, if I remember right, or 25. I forget what that inner diameter is, but it's obviously a lot smaller. Just doing a time check, 8 minutes. So that's your orientation. So that's the first thing I do. Now remember, the battery's in. These contacts are live. So don't short them against the metal. Okay. And now what we want to do, now this is keyed. And what I mean to say by keyed, where's my mark? Okay. What I mean by keyed is if I put it in this way, the vents align differently if I put it in this way. Now the vents will, so if we use the recharge port and the switches as a point of reference for alignment, putting it in one way, the vents will be to the side. Putting it in this way, the vents would be oriented with. So I opted for a specific orientation and I added a color mark, which you won't be able to see, but I put a mark with a marker there, and I put a mark on here, so I know, so this way I can remember which side. So now again, remember, this is live. These are live. Don't accidentally hit it with the coupler, or you'll short and spark the battery, right? Because you have. So this is what I do. Orientation here is not important because there's no recharge port here. So it doesn't really matter where this chassis or how this chassis gets oriented. So we'll just do that and lock it in. I'll put that up here for now. Not functional. It's just a battery. That's all it is. It's just a battery. It's not powering that. The Proffieboard powers the emitter. These switches are not active. So all that is holding a large battery. This chassis, right? Now this one's going to go in this hilt. And I've added a crystal chamber feature for the vent holes. So for now, all I have is I have a strip, a BTF lighting strip of 12 pixels to add crystal chamber effects, and obviously wires coming from this connector all the way up. I have a 28 mil bass speaker that's recessed, so this hole here allows the speaker to be inserted and then pushed up. And what I'm going to design is just a small little cover so that you can close that. If you ever needed to access it, I guess you could take it out, but my intention is part of the install, you'll cover it, glue it into place, and really shouldn't be, you shouldn't have to take that off. I 3D printed sort of a diffusing material so that this way you don't see the strip, you don't see the wires that are running. This is just kind of slid into place and will be held in place once it's in. So I'm not gluing this into place. It's not a perfect fit, as you can see. So, I might try to redesign this a little bit to close that, to try to close that spacing a little bit better, but what else? We have our 1.3 recharge port. Obviously we have our Proffieboard. The way I wired the Proffieboard, I have LED pads 2 and 3 with data 1 going to one blade. I have LED pads 4 and 5 with data pad 2 going to the other blade, which would go through the connector up into that. And then for the crystal chamber, I have, I think I did LED pad 6 with data 3, and that's going through here. Now, I guess I could have maybe gone a little bit more fancy and ran my data 2 line in series through the PTF strip and then to the connector, but that's complexity that was really not necessary. So instead I just ran it separately off LED pad 6, a separate data line. So 3 data lines, 3 blades. Well, technically more than 3 blades because I'm using stock in series, so each stock PCB is 2 blades. So 2 blades, 4 blades, 5 blades. The crystal chamber is blade number 5. So that's for each preset, there's 5 styles, okay? Okay, so that's a rundown of this chassis. So what I do, now again, if I put this in, it's going to make a connection, it's going to activate.
Open yourself to the power. Let the force flow through you.
Okay, because all that's doing is now making connection to this PCB, which is obviously driving the battery positive and negative. Still no switches. Okay. I could put my recharge port in there if I wanted to deactivate, or which you really should get in the habit of doing. I should probably have done that and then pushed it in and then removed it.
Then I suggest we move on.
But this is, this dimension matches this dimension, so there's not like a lot of wiggle room in here. So that's going to make a nice clean joined connection. So with that said, the way that I do this is I put the staff mode into the staff side hilt first. Okay, and I orient. Now orientation here is important because you want the recharge port through the porthole. Now I put this here. This serves 2 purposes. It'll ensure that once these pieces are connected, the power doesn't go to the board, but it also helps to keep this from twisting. So now as I assemble, so that noise you're hearing is the diffusion material turning and rubbing up against the vents, which is fine. So I get it as far as I can. you're gonna start to feel some resistance. And now what I do is I kind of reorient this as I tighten. And once I get a little bit of pressure, I remove it.
Open yourself to the power. Let the force flow through you.
And now I'm going to complete the twist so I get my timing right. So if we're looking down the hilt, now we have the right timing. Now my recharge port turned, so what I'm going to do is back this out. Until I see the recharge port there again. Okay. Okay, I'll add my recharge port. What I'm fearing, and I'm trying to do this carefully, is I don't want to turn it too much where this breaks and gets snapped into place. So there you go.
Then I suggest we move on.
So that's good enough, right? Does it have to be perfectly centered? No, because I can still put this in to do my charging. Doesn't have to be perfectly centered. And now I can add my cap, my porthole cover. I have Fernando's, or I have Fett's kit accent style going when the saber is off, in gold color. Okay, so that was a nice touch. Now again, is it perfect? No. I can still see some of the wire, right? So still some work to do. We'll just look at this side instead, because this side's nice. So again, buttons, these buttons are for show. They don't do anything. But now I can activate. I got color on this side. I got color on this side. And those are powered from different pads and are controlled by different data lines. So while they're styled the same and they're going to do exactly the same things, they don't have to. You know, in my case, I have two different length blades. So I could configure one side for my shorter blade. I can configure the other side for my longer blade. Right, that's the control I get. But it's all being powered from one battery, one Proffieboard, one speaker, 28mm speaker, awesome venting, sound. It's getting vented right through here. I think this is only even at 1500, the volume, so this could get boosted way up. But that's, you know, that's it. Say hi to Puppy. So I am going to I'm gonna stop the video and start it again, and this way I'll just, you know, I'll wrap it up. Okay. I think it's this side. Okay, so you know, there's still more. I have some more ideas. I wanna maybe weather my hilt, my hilt, probably just aluminum black, and you know, make it look old and aged as it is. I might still tweak the chassis as I was talking about. Maybe add a 2.1 recharge port if I can manage that. Maybe add a recharge port on this side. Maybe a kill switch. I'm not sure about the kill switch. I'm thinking it might just be better to create some sort of kill key that, you know, you just take this off and you drop the kill key in, kind of like what I'm doing with this, instead of a kill switch, because the kill switch, you're gonna have to take it apart to get to the kill switch, and the whole point of this is so that you don't have to take it apart. I can leave it in staff mode. I can recharge through the porthole. And this does have the idle idle timeout feature in ProffieOS, so the LED pad's power will get killed after 5 minutes. It's a very large battery, a lot of capacity. I really don't think a kill switch is needed. In fact, as I think it and talk it through, it's probably more of a hindrance than it really would be of a benefit. But hopefully I've showcased, right, that the whole intention was to showcase just what these PCBs are going to be able to do for the community. I know there's other people making their own. Other people have shown how these combination PCBs can be used and how useful they are. However, I don't know that I've seen yet somebody post an example of sort of these hot swappable chassis designs, right? Converting a staff to 2 different hilts. Darth Maul's original staff comes to mind. The Fallen Order staff comes to mind. The Parks OWK hilt comes to mind. While it's not a staff, I definitely have ideas on how I could use this in the emitter to allow for a removable chassis, right? Because the switches are up in the emitter. I could do a very similar design where I have a switch holder that remains in the chassis, that remains in the emitter, and the chassis just slides out, just like these do. So lots of applications, and I can only imagine and hope that chassis designers like Goth can take advantage of these in their chassis designs. I think this is a really good thing for the community. Okay. I love your feedback. I personally, I'm loving this. I'm not trying to say that this chassis design is awesome. It's not, certainly by no means, a Goth level of chassis design, but I think it definitely did its purpose, showed its function and its potential, and that was my goal. So I'd love your feedback, though. Comments, reach out to me if you have questions. Leave some comments with some feedback, guys. Thanks for watching.